Okay, this will be our final problem on this section, 15.1.2. Again, it's about finding the volumes of these shapes where the bases are a little bit harder to find, not just ordinary rectangles. In this case, it's a triangle, so let's draw it. We're going to find the volume that's below z equals xy, which is sort of a hyperboloid cap. Together with these three vertices are going to form a triangle in the xy plane because the z component is 0 for each. And let's see what that triangle looks like. So we just need the first quadrant, xy. And then it's the point 1, 1, 4, 1, and 1, 2. So not too bad. It forms a triangle that's actually two of the sides are parallel to the axes, so much easier to envision and also easier to integrate. Okay, so once again, here's our little rectangular piece of how we're going to sort of envision integrating to find the volumes. X will actually go from 1 to 4, so I'll just go across in the x. And then the y needs to go between these two bounds. You can notice there's a piece missing at the bottom, so y has to start at 1 and finish at the equation for the line. The equation for the line is actually y equals negative 1/3 x plus 7/3. And I found that by just plugging in the two endpoints for slope and to find the intercept. So we can simplify that as a function. It's 1/3 times 7 minus x. So that's probably the easiest bound to plug in. So there it is. In order to integrate, again, this becomes our cap, and our base is defined by x between 1 and 4, and y between 1 and the top of the line, 1/3 of 7 minus x. So here's the integrals. So the outer integral is 1 to 4, and that's the x integral. The inner one is 1 to 1/3 of 7 minus x. And then what we're integrating is xy, dy, dx. Okay, let's do the inner one. So that's 1 to 1/3 of 7 minus x, and xy, dy. So the integral's not too bad. This is just going to be 1/2 xy squared, evaluated between 1 and 1/3 of 7 minus x. So this gets moderately messy once we plug everything in, and what we end up with at the end is 1/18 of x cubed minus 14x squared plus 40x. And that's what you get once you plug in the upper and lower bound and then simplify. So that becomes the argument for our next integral, and that's 1 to 4. And the argument will be, I can put the 1/18 outside, x cubed minus 14x squared plus 40x. And once again, the integral is not hard to find. This will be 1/18 of, this will be x to the 4th over 4 minus 14/3 x cubed plus 20x squared, and that'll all be evaluated between 1 and 4. The numbers kind of turn a little unpleasant here, but once you add all the fractions together, it works out to be 31/8. And again, that is the volume under this hyperboloid that has this triangular base in the first quadrant.